My name is Tejas Kulkarni. I'm in 5th grade. I'm doing this course with my dad, and I'm hoping to learn a few new things about physics. So, you have to start with the x-y coordinates of the star's movement. You want to calculate the F-net force acting on that star. We are going to assume that this force is only because of the gravitational force from the black hole that the star is orbiting around. We calculate velocity at each point by subtracting initial position from final position and dividing it by delta t, which is 1 day, or 86,400 seconds. We get n-1 velocities using this calculation, where n is the number of positions. We also calculate the average distance from 0, 0, 0, the black holes. That's where the black hole is, for each point r. Now we calculate velocity and momentum changes at each point using the calculated velocities. We get n-2 velocity and momentum changes. Using Newton's second law, at each point, F-net is equal to the mass of the star multiplied by delta V over delta T. So F-net is equal to delta P over delta T, which is the change in momentum. F-net parallel is the change in magnitude of momentum vector over delta T, and F-net perpendicular is F-net minus F-net parallel. Now we can equate this force to the gravitational force. We know F-net is equal to the gravitational constant multiplied the mass of the star times the mass of the black hole divided by r squared. We know everything but the mass of the black holes, so we changed the equation so we could figure out the black hole's mass. So the equation is now the mass of the black hole is equal to F-net multiplied by r squared divided by the gravitational constant times the mass of the star. And with that equation, we figured out that the black hole's mass is equal to 2.08910 raised to 31 kg. This is about the two different questions asked in the lab. So the first question was the difference between the F-net parallel and F-net perpendicular and corresponding momentum vectors like delta P over delta T, delta P perpendicular over delta T, and delta P parallel over delta T. The force F-net is what is causing the change in the momentum vector and the velocity. F-net parallel and F-net perpendicular are the parallel and perpendicular components of this force. Though the change in momentum vector per unit time is the same as F-net, it is not what is causing the change. We can say the same of the parallel and perpendicular components of the momentum vector. The second question was, what if we replace the black hole with another black hole with the same mass? I think that there would be no change in the star's motion as long as the new black hole had the same mass and same location. I'm now going to run this in VIDLE. So the star's mass is 1.9810 raised to 30, and we figured out the gravitational constant right here. Delta T is 1 day, and the time we're starting at is 0 seconds. So the first while loop is here. That's and the second while loop is doing all the calculations. So we figured out the P initial and P final, and we found delta V and delta P. We've set F-net as dP dt, and dP dt is equal to delta P over delta T. P hat, the unit vector is the P initial over magnitude of P initial. Then the dP dt parallel is equal to F-net parallel, so and F-net perpendicular is equal to dp/dt perpendicular. And we used arrows to represent fnet parallel and perpendicular. So the yellow arrow that you're going to see when we run the module is the fnet. The black arrow is the parallel, and blue arrow is perpendicular. So this is the formula we use to calculate the black hole. We're going to print that, and now we're going to run the module.